Hello guys, so here is a problem. A point R is 40 mm below HP and 35 mm in front of VP, also 25 mm from RPP, right profile plane. Draw its projections. So this is the problem statement. So it is understood from the problem statement that the point lies in fourth quadrant, right? So write on that fourth quadrant, correct. So it is the point that lies in fourth quadrant because the point R is 40 mm below HP and in front of VP. So below HP, in front of VP, it is fourth quadrant, correct. Fine. So now let me draw that fourth quadrant in 3D. Okay, I'll do that. Okay, so I have taken fourth quadrant in 3D. So now let us try to locate the point. It is 40 mm below HP and 35 mm in front of VP. So somewhere here it is. So this distance is 40. This is 40 mm, correct. So this is 35 mm, right? Correct. So this is the position of the point R. Fine. So as you all know, our observer is here. So his position is fixed. He'll observe the point from his position. So the front view of the point will be projected on VP and the top view of the point will be projected on HP, right? Similarly, the distance 40 will also be projected on VP and the distance 35 will be projected on HP, correct. So I'll draw the shadow lines. Okay, so let me complete this. Fine. So now if this is 40, this will also be 40, and if this is 35, obviously this is 35. So finally we have located the point and we have taken its shadows, right? Now we have to rotate HP 90 degree clockwise to make it a single plane, correct. So now let us rotate HP 90 degree clockwise. So after rotation, okay, I'll try to get that view. After rotation, what happens? HP will come down. That means both HP and VP will be below XY line. So let us try to locate that. Okay, so this is what happens after rotation. Both VP and HP will be below XY line, but since it is fourth quadrant, HP will overlap VP, so the observer cannot see VP, so he can see only HP. So we have to put bracket for VP, because you can observe here, see XY line, HP, once I rotate HP will come above VP, right? So observer cannot see VP directly, so that is why we have to consider bracket for VP. Okay, now let us try to locate the points. The points are 40 and 35 and both are below XY line, so both should be below XY line. We have to represent. Okay, so I'll represent both the points here, one being 35 and another being 40. So this is 35 and this is 40, right? This is 35 and this is 40, correct. So roughly I have taken this. We still have to generate the required solution. Okay, now let us try to locate the notations. The 35 distance is top view, so the point is R and the 35 distance is top view. As you can observe here, the 35 distance is top view and the 40 distance is front view, right? So since 35 is top view, it is simply R and here it will be R dash. Also on VP we can see top view or front view. So front view should be within the bracket, because see here on VP 40 distance will come, so for the 40 distance we have to put bracket because it is hidden because of HP after rotation. Okay, now we'll try to generate the solution, final solution. Okay, observe this now. I have drawn XY line and I have shown both VP and HP below XY line since it is fourth quadrant, and VP within the brackets because it will be hidden to the observer. So now I locate 35 and 40 distances. Guys, you have to take actual measurement, but here I am roughly showing it. Okay, so it is 35 and 40 lines. I'll give the notations for this. Always we have to show the smaller notation first and after that the bigger one. So it is 35, so show that 35 first and after that the 41, bigger one. Okay, and we know the 35 distance is R and 40 distance is R dash within the bracket, so you should not forget the bracket. Okay, now in the problem what he has given, see, in the problem he is talking about RPP, so we have to consider one profile plane towards the right of the solution because he is talking about RPP. So coming down to the solution, and the distance of RPP is 25 mm, correct? So we have to consider one plane exactly, that is x1 y1, and that is RPP towards the right of the solution, and we should be exactly 25 mm from the solution we have already generated. Okay, now we have to search for the top view. Where is top view? The point R. So exactly opposite to that, on the other side you have to draw one 45 degree line. So you have to measure it properly, 45 degree line, and you have to draw. So I have taken 45 degree line roughly. So next, from top view we have to connect to the 45 degree line. So we have to draw one line from top view to the 45 degree line, correct? So now next, here we got an intersection, right? Next we have to search for front view, and towards front view we have to draw one more line. So front view is here at the bottom, so we have to drop down a line from this intersection, and we don't know where to stop, so draw an infinite drop down line. Okay, fine. Next, from this front view point you draw one more line till it touches the recent line which we drawn. Okay, so draw this. So here we got one intersection, the latest one, so this intersection will be my R double dash, that is my side view. Okay, so in this problem he is talking about RPP, and which is in fourth quadrant. So what happens in first and fourth quadrant? In first and fourth quadrant, left side view will be projected on RPP. So the type of view is left side view. Okay, so this is the type of view. So this completes the solution. Okay, thank you.